Whoa, focus. Okay, a unit vector is a vector whose magnitude is 1. So if I have any old vector A, say, the unit vector that goes in the same direction as A we can find we'll call it U for unit, and it's that vector divided by its magnitude. We could also write that 1 over the magnitude times the original vector. So notice that a unit vector in the direction of A is a scalar multiple of A, 1 over the magnitude. That's a scalar. Just to try and convince you that this really does give something a vector whose magnitude is 1, if I do the magnitude of a unit vector like this, wow, the magnitude of the denominator, well, it's already a magnitude, so its magnitude is just itself. On the top, I have the magnitude of the vector. And so that's the same thing divided by itself, which is 1. It really does work. For example, if I have the vector 6, 0, negative 2, if I want a unit vector going in the same direction as that vector, first I need its magnitude. So square root of the squares of the components. And let's see, 36 plus 4 is 40. So known as 2 root 10. So the unit vector in the direction of A, I could write 1 over the magnitude times the vector. So the unit vector is still a vector. It's just different length than the original. Or I could write each component over that magnitude separately. So let's see, 6 over 2 root 10. 0 over anything is still 0. That's nice. And negative 1. I'm going to take this opportunity to say a couple things about notation. First of all, I can't say this enough times. I probably have said it before, and I'll probably say it again. If it's a vector, it needs the little arrow over top. Has to have it. If it's not there, it's not a vector, it's a scalar, and that's a whole other ball of wax. The other thing, what was the other thing? Oh, rationalizing. You don't have to. I trust that you can do that at this point in your mathematical career, and 3 over root 10 is fine with me. If it bothers you, go ahead and rationalize it. Just make sure you do it right. But for me, you don't have to do that. Well, it's convenient to have standard unit vectors that go in the directions of the axes. So we're going to call those, if you take physics, you're probably really familiar with these. So I goes in the direction of the x-axis, so its coordinates are 1 in the x direction and 0 in the y and z directions. Magnitude is 1, goes in the direction of the x-axis. For the y-axis, we use j. Never quite sure what to do when there's both a dot and an arrow. That's 1 in the y direction and 0 in the other two. And k is 1 in the z direction. So if I want to write my original vector A, 6, 0, negative 2, using the standard unit vectors instead of component form, that's what this is with the pointy brackets, I can rewrite it. That's 6 in the x position, so that's 6 times I, 0 times j, which I'm not going to write because it's 0, and then negative 2 times k. So A is 6, 0, negative 2, A is 6i minus 2k. Those give exactly the same information. Speaking of ways to give the same information about the same vector, another way we can look at these is think of the unit circle. I'd have thought you were free of that, but you never are. So if we have a unit circle, there it is, and we have a vector in standard position, goes like this, somewhere, I don't know, has an angle. If it's the unit circle, by definition of what the unit circle does, I'm going to name this vector u. As you've seen in other contexts, probably has coordinates. X coordinate is the cosine, and the y coordinate is the sine of whatever that angle is. Well, suppose it's like the 5-unit circle or the 12-unit circle instead of the unit circle. Well, the angle is the same, the cosine theta and the sine theta. The only difference is we have to go out farther to get there. So instead of just one cosine theta and one sine theta, we can express, if it's not a unit vector, using the magnitude. So if u is not a unit vector, then we get we'll just multiply by the magnitude of u to get the coordinates. Oops, those go in between there. There we go. So for example, if I know that my vector has a magnitude of 4 and an angle of 2 pi over 3, I can write the component form of this vector by multiplying the magnitude by the cosine and magnitude by the sine. So let's see, 4 times cosine of 2 pi over 3. I'm going to cheat and draw my little triangle here because I don't want to get it wrong. There we go. Cosine of 2 pi over 3 is cosine of pi over 3, except for it's negative. Pi over 3 is right there, so that's a negative a half times 4. And sine of pi over 3 is, or sorry, 2 pi over 3 is root 3 over 2 times the magnitude. So we got negative 2 and 2 root 3. Just another way of expressing a vector.